In this video, we will look at proposition 3.4.2 and example 3.4.2. We're continuing to look at the number of solutions of homogeneous linear systems. Proposition 3.4.2 tells us that a homogeneous linear system with more variables than equations has infinitely many solutions. Let's prove this. So let H_aug be the augmented matrix of a homogeneous linear system, and let H be the corresponding coefficient matrix. Now we've seen that homogeneous linear systems are consistent since the rank of H_aug, the augmented matrix of the homogeneous linear system, is equal to the rank of the coefficient matrix, H, of the linear system. Now we want to prove that a homogeneous linear system with more variables than equations has infinitely many solutions. Now how does the rank of the augmented matrix compare to the number of variables of the system? First, what we'll do is compare the rank of the augmented matrix with the number of equations in the linear system. Now the rank of the augmented matrix is always less than or equal to the number of equations of the linear system. And why is that? Well, that is since there are at most as many leading entries as there are rows in the augmented matrix. If a linear system has 3 equations, then its augmented matrix has 3 rows, and the maximum number of leading entries is 3. So the rank can be at most 3. That's why the rank of the augmented matrix is less than or equal to the number of equations. Now what we're trying to prove in proposition 3.4.2 is that a homogeneous linear system with more variables than equations has infinitely many solutions. We haven't used the fact that we have more variables than equations yet. This is when we're going to use it. If we have more variables than equations, then the number of equations is less than the number of variables. This is by assumption. And so what we found is that the rank of the augmented matrix is less than the number of variables. When the rank of the augmented matrix is not equal to the number of variables, the corresponding linear system has infinitely many solutions. So therefore, the corresponding linear system has infinitely many solutions. Which is what we wanted to prove. Let's look at example 3.4.2. In example 3.4.2, we want to determine the number of solutions the linear systems corresponding to the following augmented matrices have. In part A, we have an augmented matrix corresponding to a homogeneous linear system. We see this because the column of constant terms is filled with zeros and only zeros. Now we can use proposition 3.4.2. It tells us that a homogeneous linear system with more variables than equations has infinitely many solutions. Well, how many variables do we have? We have 4 variables. And how many equations do we have in this case? We have 2 equations. And so we have more variables than equations. By the proposition, we can conclude that the corresponding homogeneous linear system has infinitely many solutions. Now let's look at part B, and let's again find the number of variables. The number of variables is again 4. and the number of equations is again 2. But can we make the same conclusion? Can we say that 4 is greater than 2 and conclude that the corresponding linear system has infinitely many solutions? We cannot do that in this case because this is not an augmented matrix corresponding to a homogeneous linear system. The constant terms are not 0, they are 1 and 2. So we cannot use proposition 3.4.2 to conclude that the linear system has infinitely many solutions. We do have that the number of variables is greater than the number of equations, but that doesn't necessarily mean that the corresponding linear system has infinitely many solutions. In fact, we can see that the rank of the augmented matrix is 2, while the rank of the coefficient matrix is actually 1. And so the corresponding linear system actually has no solution.